Good evening. My name is Brian Grimkowski. I'm one of the assistant directors of graduate admissions here at William Patterson University. I'm joined by my colleague in my office, Christina Aiello, as well as Dr. David Snyder, who is going to be talking in just a few moments about our MS in material chemistry here at William Patterson. A couple things, just housekeeping items before we get started. First, I want to make sure you know that we are recording this presentation in its entirety and are going to be making it available on our YouTube channel. So we realize that now more than ever, time is very precious. Everyone is very busy. Schedules can be very unpredictable. So for any reason you need to leave a bit early, we certainly understand, and you would have the chance to listen to this presentation, part of it or in its entirety, from the comfort of your couch or wherever else is most convenient for you at a later date. So you can expect to see an email from us before the end of the week with the direct link to our YouTube channel if that would be helpful. And also, if you have any colleagues, any family, friends, or otherwise that you think might benefit from the opportunity to hear the information that we have to present for you today. We do want to give you a lot of information in a relatively short amount of time. We're sensitive to your time. We want to make sure that whether it's plans for dinner, whether it's virtual learning, whether it's work or otherwise, we want you to be able to get back to the things that you need to do after you get the information that will be helpful for you. So certainly keep that in mind as well. Lastly, as we go through, if you have any questions that you think of that you want to be addressed, you can type them in the chat box on the GoToWebinar screen. If it's something very simple, admissions related, a question that we can field for you quickly, we'll just type an answer. If it's something that would be a benefit to the full audience to hear, we'll read it off on the tail end of our presentation as a part of a question and answer session. So I know you're not here to listen to what I have to say. You want to hear about what Dr. David Snyder has to say about our materials chemistry program. So without further ado, Dr. Snyder, take it away.
Hello, thank you for the introduction, Brian. I'm Professor David Snyder. I'm the program director for our graduate program in materials chemistry. So, me just experiencing a wee bit of technical difficulties here with my PowerPoint. So, our program is actually a fairly unique program in that it is one of the few, if not perhaps one of the only material chemistry programs. What distinguishes us is that we're housed within a chemistry department. So our focus is on basic research, and as a faculty tends to be on basic research and more the actual science of materials. That being said, materials chemistry is a technological sort of program with very definite engineering applications. So we kind of are at the intersection of more traditional engineering and more traditional chemistry kinds of studies. And our faculty has a range, as we'll discuss later on in this webinar, a range of expertise in all areas of chemistry, ranging from physical and theoretical chemistry to very practical synthetic and analytical chemistry. So we'll begin the webinar with some program information, and information not just about the program, but also about the department and the facilities. And we'll discuss a little bit the curriculum of the program, including a suggested sequence of courses, and then some practical information about applying to the program. What are the features of this program? As I said, this is a very unique program, right? Materials chemistry is at kind of the intersection of a number of fields, material science, chemistry, materials engineering, and materials is itself, it's a broad thing. What is a material? Well, pretty much everything we work with is some sort of material, right? This computer that I'm using to give this webinar, it's made out of various high-tech materials. And so materials chemistry students learn how to do some really hands-on work with materials, both theoretical modeling of materials, how to model the properties of all sorts of different solids and liquids and other advanced materials. We have a lot of faculty expertise in nanoparticles and things called metallo-organic frameworks, which are an exciting new class of catalysts. So we have, and we even have people who do biological materials. Professor Cower does some studies of peptides and sort of and other biological materials. I am a biochemist. I've done some studies related to biological materials. I hope to go even into studying other biological objects like fossils and other sorts of things. So there's a range of research and a range of knowledge research you can take part in as a materials chemistry grad student. There's a range of knowledge you'll obtain, and it's really practical sort of knowledge, but based within a very solid theoretical framework. We actually have fairly extensive facilities. You can see Professor Xing working with actually, I think at the time, I forget, he was an undergrad or a grad student. Me working with a grad student, actually, he was in the biotech program, I believe, or was the bio program. Shiva Patnala, Professor Jitianu. We actually do interdisciplinary work. We have collaborations with other departments at William Patterson. As I mentioned, I've supervised grad students in the biology department as well as a biochemist. I've worked with the biology department as well as with the chemistry department. There are opportunities to engage in collaborative research with other research groups. I've had undergraduate students even involved in international research collaborations. For the facilities, I've kind of gone on a tangent here. Within our department, we actually have some very extensive facilities. We have a 400 megahertz NMR machine capable of doing both solid state and liquid state NMR. It's a pretty impressive NMR machine for a school of such as William Patterson. Many of our peer institutions will not have quite as impressive of NMR spectroscopy capabilities. We also have a rheometer that measures the viscosity and other rheological properties of liquids and semi-solid materials, operated by Professor Jitianu, and extensive facilities for both synthetic chemistry, analytical chemistry, and even theoretical and computational chemistry. Here is a list of some of the things that we have. I'm not quite sure of all of your interests. We have, in terms of computational work, we have two main computer centers within our department. One is the 10-node HPC cluster. The other is a more informal cluster with some very impressive Xeon processors. And we do both classical molecular dynamics and quantum chemistry, as well as classical electrodynamics. There'll be ample time as a graduate student to learn how to use imaging instrumentation, all the various synthetical and analytical instrumentation available within our department, as well as computational techniques. So what can you do with the materials chemistry degree? It's actually a very wide range of fields to which it is applicable, ranging from the biomedical end, hospital labs, environmental end. You can work in an industrial setting or in a government or university setting. We actually have within our department a lot of faculty who are active in generating intellectual property. In particular, we have faculty with multiple patents. So as a graduate student in materials chemistry, you'll actually gain experience with creators of intellectual property who understand the IP laws and also the patent process. So you can learn about a lot about the patenting process, which will set you up for work as potentially a patent agent or technical writer. This is a good introduction if you are not quite sure whether to go on and get a PhD or to have a master's as your terminal degree. Having a materials chemistry degree will give you a lot of flexibility. Because our program is very research oriented, you will have experience doing research, which will prepare you for a PhD program, as well as provide you with enough experience and training for our program to serve as a terminal master's program. Of course, in New Jersey, the pharmaceutical industry is big. We have graduate students within industry who are part-time graduate students or even full-time graduate students taking classes in the evening and who are still working and receive support from their employer to be part of our program. In fact, two such students we've highlighted as success stories, both of our undergrad program and our graduate program. These students both worked with Professor Cower in her lab doing organic synthesis. But as doing work in organic synthesis involves a lot of work, not just in synthetic techniques, but also characterization, analytical techniques, such as GC, mass spec, MR, liquid chromatography, such as HPLC. Our students publish as co-authors, and many of our students have co-authored papers as part of their master's program. As I described, we have quite a broad range of faculty expertise. Our faculty collectively cover all branches of chemistry. There is more up-to-date information on our faculty web pages. Some faculty, in fact, have created lab web pages where you can find out more about the research that we're doing. Professor Chauhan is a noted expert in nanoparticles and nanoscale materials. He's written a book on it, or well, edited a book on it. Professor Foley is a theoretical and physical chemist who does a lot of work with both quantum chemistry and classical electrodynamics. Professor Foley and I will you join us for our graduate study. Professor Foley and I co-teach the theoretical and computational chemistry course. He teaches the quantum mechanics section and the electrodynamics section, and I teach classical mechanics. So he does a lot of research with photonics and light matter interactions. It's quite fascinating. If you have a chance and haven't already heard him speak about his research, you need to hear him because he's quite a dynamic speaker. Professor Jitianu is also one of our more classical materials chemists. Professor Chauhan and Professor Jitianu, while all of us have materials directions in our research, Professor Chauhan and Jitianu, as well as Professor Foley, really are kind of the hardcore. If you think of like what materials are intuitively, like concrete as a material, or a piece of paper as a material, all those sorts of things that kind of solid things that you can hold in your hand, whether at the nanoscale or at larger scales. Professor Jitianu does a lot of research with essentially synthetic minerals. So you can actually make minerals in the lab and do inorganic synthesis and then characterize those materials, which are potentially useful catalysts, especially for environmentally friendly chemistry, green chemistry, dealing with remediation of contamination. It's a very very exciting field. There's a lot of work actually going into fixing up the mess we're leaving on in this planet, and Professor Jitianu's research is central in that. We do a lot of mentoring as faculty of graduate students within our department, and we're very proud of the degree to which we involve students in the research, not only to give them research experience, but also experience in problem solving and other practical skills that students use when they graduate and go into jobs that expect you to be able to solve problems when they come up in a very practical and focused way. Professor Cower and I both have a connection. We both at UC Irvine. She is a postdoc relatively recently. Me, a long time ago, or maybe not that long ago, but it's now, I guess, fair enough to say a long time ago as an undergrad. Professor Cower does a lot of bioorganic chemistry from a synthetic perspective, including chemical biology, which is a field that is extremely fascinating. And there are lots of, if you want to think about a lot of what's going on nowadays with vaccine development and with trying to rapidly develop new drugs, there's actually a lot of materials chemistry that goes into that. The pharmaceutical field, even though we don't think of drugs and pharmaceuticals as materials, there's a lot of material aspects to shaping pills and how you actually can deliver medicine that survives the digestive system and is well absorbed. And by the way, I forgot to mention Professor Chauhan works on some of that, the kind of materials aspects of drug delivery. And Professor Cower works not only on synthesis of molecules that are of pharmaceutical importance, but also looking at various catalysts that are important in those syntheses. And some of those catalysts are very not only important in green chemistry, but they're also, you can study them very, it's very important to study certain catalysts from a materials chemistry perspective. So if you're interested in catalysis, which is something that's very critical in industrial chemistry, our program will give you a lot of useful training in that field. And yours truly, I do a lot of research with NMR. I helped develop a technique called covariance NMR that takes NMR spectra that are easily acquired and uses them to reconstruct spectra that you cannot experimentally acquire. So it's the combination that I'm interested in, how to use computational techniques to maximally leverage experimental data. So a lot of my work is at the intersection of computational chemistry and experimental chemistry. Professor Jing is a synthetic chemist who does, like both Professor Jing and Professor Cower, are interested in a particular class of hybrid organic / inorganic materials called metallo-organic frameworks. Professor Jing also is interested in photocatalysis. So just as Professor Foley is interested in the interactions of light and matter from a theoretical point of view and studying how materials interact with electromagnetic fields, which is a very important area to understand theoretically. Professor Xing is very interested in applying, in learning how materials and electromagnetic radiation interact from the point of view of developing better synthetic techniques and better methods, ways to catalyze chemical reactions. So I hope this has given you a good overview of the faculty that you'll have a chance to do research with as a graduate student, should you choose to come here. So our courses, right, there is a required research component. In fact, you will be doing research over the course of 3 semesters, and you have the opportunity to start doing research as soon as you come here. I know some of you are already in research labs at William Patterson even now, and you can continue that research at the graduate level. So the core curriculum within our program covers all aspects of materials chemistry: inorganic materials, organic materials, how to synthesize materials, how to analyze materials, and also how to understand them from a theoretical and physical chemistry point of view. Then not only will you have research, but you will learn about how to present research, and you will have an opportunity to learn about the breadth of materials chemistry research within our graduate seminar. You will also have the opportunity to focus on some particular aspect of materials chemistry through not only your research, but also elective coursework. There is the possibility of substituting a required research course with an industrial internship. So we do have ties to industry, and depending on your focus, you can focus more on academic research or industrial research. This is the sequence of courses, how if one started in, say, the fall of 2018, how they would be able to finish by the spring of 2020. And you can kind of translate this to fall of 2020 to spring of 2022. What is required, right? I mean, the key thing is that you are prepared to jump right in with graduate level coursework in materials chemistry. What does that mean? That you have a bachelor's degree in chemistry or a related field. Related could be fairly far afield, right? There are a lot, since chemistry, everything's really about chemistry. Chemistry is everywhere. It's the undergraduate textbook we use puts it. Chemistry is the central science. Really, we take a very broad view of related field, provided you have adequate preparation in physics and math and some maybe first year undergraduate chemistry courses in organic chemistry, essentially what you need to jump right in to study. And you can always, if you're otherwise qualified for a program, you can always make up appropriate courses, and the graduate committee will work with you on that. These more data, more information, and in fact, a lot of what I've shown can be found on the internet as you search and try to research our program further. And I am available, as well as Professor Chauhan, and the faculty of the department as a whole are available to answer questions. Of course, it's hard to do so in person with things being what they are, but we can answer questions by emails. Of course, we can also answer questions right here. So on that note, our greatest strength is helping you find yours. Have Professor Chauhan's email. I can leave, I'm not quite sure if I have the ability to send out my email to everyone, but I'm sure you will at some point receive it. Professor Chauhan is our department chair. I'm David A. Snyder, the graduate coordinator for the program. And our program does offer graduate assistantships. So you will have the chance, I don't think we have one for all graduate students, but select graduate students do have the ability to receive some funding for the graduate education, as well as obtain hands-on experience in teaching lab courses and the like. We do perform top-tier research. We're a very research-active faculty that will provide you hands-on experience in one-on-one mentoring. And actually, it says just 20 miles to NYC, but as I am presenting this to you, I happen to be sitting in my apartment within the boundaries of New York City. So on that note, I will just ask any questions.
Thank you very much. At least as of right now, we haven't had any questions come through, but if you do have any questions, would encourage you to type them in the chat box there on the GoToWebinar screen. One thing I figured I'd elaborate on real quick that Dr. Snyder was just talking about, just for some further information about grad assistantship positions. If that's something that could potentially be of interest for you, the way that you get consideration for a grad assistantship position is one of the questions on the online graduate application is, do you want to be considered for a graduate assistantship? If you click yes, that information will go over to the provost's office. As a part of the review process, they will look at all the applications that come through, and there really are appointments all over campus. We have a graduate assistant in our office in graduate admissions. Many of the academic departments have one or more grad assistants, everything from marketing and communication, the athletic offices. There are a number of different places where appointments can take place across campus. In order to be considered, you have to apply before March 15th. And the bulk of the positions are allotted for the fall semester because the appointment timeline is from September 1st through June 30th. It includes tuition and fees being covered for the time of the appointment, and then there is a $6,000 stipend that's broken down in the form of biweekly paychecks between the fall and the spring semester. And then the caveat is that you would work for 20 hours per week part-time for one of the departments here on campus. So just wanted to make sure that you were aware of that opportunity in case that was something that could potentially be of interest for you. And if anyone has any other questions, you can type them in the chat box on the GoToWebinar screen there. We'll give it just a moment in case any others come through. I just want to mention for anybody that joined us a little bit late today, I do want to make sure you're aware we did record the presentation in its entirety. So that means you're going to get an email from our office before the end of the week that will include the link to our YouTube channel where you can take some time, whether it's on the couch or otherwise, to listen to it at your convenience. So you will be getting that email from us. Be on the lookout for it before the end of the week. But it looks like there are no questions as of right now. So we are going to stick around for a couple minutes in case you do think of any other questions. But I want to thank all of you again for taking time out of your schedule to join us today. Again, I know time is perhaps even more precious than in the past, and we appreciate whether you took a break from family obligations, work obligations, everything in between. We really do appreciate your time. If you like what you heard today and you haven't yet considered submitting an application, I would encourage you to do so. David, can you hear me okay? Can everyone hear me okay? I believe, can everybody hear me okay? Can everybody hear me?
I can hear you.
Okay, sorry, I thought my audio cut out for a moment, or I got a message that my audio cut out. I do apologize. So if you are interested in what you heard today and you're giving thought to submitting an application, the next available term to be considered would be our spring semester, which starts on January 21st. So you could consider applying through our application, and then all of the application requirements were covered before. Sorry, we had an audio issue before. I apologize for any confusion that caused. That threw us off for a moment. But it looks like there are no other questions. So I want to thank everybody again for your time this evening. We certainly hope that you enjoy the rest of your week. If you haven't already submitted an application for the program, we hope to review your application in the near future. And then as Dr. Snyder referenced before, he'd be very happy to hear from you, as would the other faculty members on the department. On the screen right now, you can see the contact information. And then if you have any questions for the Graduate Admissions Office, we can always be reached at graduate@wpu nj.edu, and we'd be happy to answer any questions you might have about the application process. So thank you all again. Be safe, and we hope to hear from you soon. Take care.